consider the situation shown in the figure. The bottom of the pot is a reflecting plane mirror. Alright, this is my plane mirror. S is a small fish and T is a human eye. Refractive index of water is mu. At what distance from itself will the fish see the image of an eye? Alright, the fish is seeing the image of the eye. So there are two cases. If the fish is seeing directly at the eye, from this surface, then it will see an image, obviously. Now let's say the initial distance of the eye from this surface is h, that is given to me. So the image formed by this surface of the eye will be calculated by that very formula, that is mu of the air and distance, that is h, from the refractive surface, and mu of water divided by the final image. Let's say it is forming at a distance x from the surface. So the value of x comes out to be mu of water into h. Now this is the location of the image that is formed by this reflecting surface. So the first image that the fish will see will be at a distance of h by 2 plus mu w of h. That comes out to be h times of 1 by 2 plus mu. This is the location of the first image from the fish. Now the location of the second image. So the second image that will be formed when the fish will try to look at the eye from the plane mirror. Alright, now what will happen is that this is the image, first image formed. Alright, and the plane mirror will form the final image of this virtual image. So it will be formed somewhere over here, and this distance will be equal to x plus h, because this is the property of the plane mirror, that object and image are at the same distance from the plane mirror. So the object is at a distance x plus h, so image will be formed at a distance x plus h. So the distance of the image from the fish will be equal to h by 2 plus x plus h. It comes out to be 3h by 2 plus x, where the value of x is mu w into h. So it comes out to be h into 3 by 2 plus mu. That is the answer. In second case, I have to calculate the distance from itself will the eye see the image of the fish. Fine, now eye is seeing the fish, so I have to calculate the distance of the images of the fish from eye. Now there are again two cases, that if the eye sees the image that is formed directly by this reflection surface. So let's say the image is formed at a distance y, so I can write mu of water into location of fish, that is at a distance h by 2 from the reflecting surface, is equal to 1 by, let's say, y. So y comes out to be h by 2 mu. So the distance of the first image from the eye will be equal to h plus h by 2 mu, because this y will be somewhere over here. So the distance from the eye is h plus y, that is h plus h by 2 mu. So h 1 plus 1 by 2 mu. Alright, now the second image will be formed if the reflection, if the eye is seeing the final image that is formed by first the reflection from the plane mirror and then its reflection from this surface. So the reflection will cause the image of the fish somewhere over here, right, at a distance of h by 2. So the second image will be formed at somewhere like distance from h plus, let's say, y dash, where y dash is the image formed of this object by the reflecting surface. So the value of y dash can be calculated by the same formula, that is mu by distance from the reflecting surface, that is h. This is h by 2, so h plus h by 2, that is 3h by 2 into mu, that is 1, let's say y dash. So value of y dash comes out to be 3h by 2 mu. So just substitute this value over here. I'll get the location of the second image from the eye, that comes out to be h plus 3h by 2 mu, that is h 1 plus 1 by 3 by 2 mu. That is the answer.